Hey, this is Shiloh Lawrence. I want to do something a little different here for Chapter 4, and I know I'm a little bit behind because your first Chapter 4 homework is due tomorrow. But some of you I know don't work on stuff till the weekend, which is perfectly fine. As long as it's done by Sunday at midnight, you do it whenever you want. I wanted to go through each of the sections here in Chapter 4 and highlight some of the important things and give you some of my own little tips and tricks for the important things. And then also just kind of skip and tell you which stuff is really not important so you don't have to stress too much about it. And I'm going to start right here in 4.1. I will warn you a couple things. The current recorder I'm using only allows for 15 minutes, so I'm going to squeeze whatever I can in 15 minutes. There's a good chance I won't finish the whole section in 15 minutes. And if I don't, then I will do a second recording to finish up the section. Also, I have 2 small children running around the house, so you may hear kids talking every once in a while. So I apologize for that. So in 4.1, we get an introduction to polynomial functions, and at the end of the chapter, they do a little bit of modeling with the calculator. And modeling means just come up with an equation. Use some data to come up with an equation. So I'll show you that when we get to it. Most likely it'll be in the second video. But here, there's a ton of information in your textbook on the very first page of section 4.1. And I've got the textbook right off the screen here to the side. But what I wanted to show you was the notes that I'm taking. And I'll also scan these notes and post them in Moodle right next to the link for the video, so you have the notes as well if you want them. So you've actually been working with polynomial functions already this semester. I don't know if we've actually used this word, though. If you look in the book, the format that they give for a polynomial function, I'm sorry, that should be a -1, looks really scary. It's got lots of letters and lots of little equations, and it's actually really simple once you know what all that stuff means. So this is just a polynomial function. One thing I noticed in the last chapter, and I think it might have actually been chapter 2, is a lot of you are still confused on function notation. These 2 pieces that we always see with function notation, the first one is just the name. So we're calling this function p. And we do that just because there's sometimes within a problem where we're dealing with several different functions, and it's easier to just say their name rather than write the whole thing out every single time. So we could say function f, function g, function p, function l. The x in the parentheses is just a little foreshadowing, telling us that on the other side of the equation, x is used as the variable. It is technically the math term for it is independent variable. That is the placeholder where we can plug things in at. So in this equation, they're using x for that independent variable. This very well could say p of t, and that means you're going to see t's on the other side of the equation. It could say p of y, and you'll see y's on the other side of the equation. In the parentheses, it just tells us what variable we should expect to see on the other side of the equation is all. And it looks like my webcam has stopped working. Awesome. Let me see if I can reload it real quick. Alright, sorry about that. I had to pause for just a second and reload the camera. So you might have been missing some of that. But p is just the name, and in the parentheses next to it is an x, and that just means, hey, just a little heads up, when you look on the other side of the equation, you're going to see x's over there. That's all that means. And this is just function notation. There'll be a name, and in parentheses there will be a variable, letting you know what variable gets used on the other side. So there's a couple things in this equation I want to point out to make it not look so scary. First of all, the a's. We see a in every single term, but it has this different little subscript. And the reason they're doing that is to just say, hey, this a goes with this power of x. This a goes with this power of x. This a goes with this power of x. So the a's, they're just going to be real numbers, and they're called the coefficients. They're just real numbers. They could be fractions, decimals, positives, negatives. They could even be irrational. You could have a pi there, which is the number 3.14 and goes on forever. As long as it's a number, it's fine. You could have radical 2 there. But those a's, they're just numbers. Going to be in a spot, and they're called coefficients. The x in this problem is the variable, and I know that because of the function notation. There's an x in the parentheses next to the name of the function. That means x is the independent variable. And it's called an independent variable because it is not dependent upon anything. It's independent in that we get to choose what we want to plug in for it. And then the n's here, n represents or helps us to represent the exponent. And those exponents in a polynomial, it's got some very specific rules that go with them. N is always going to be a positive integer. And another way to say that is a whole number. It can be anything greater than or equal to 0, but only the wholes. So 0, 1, 2, 3, 4, 5, 6, 7, all the way up. So we don't know what this n is, but this one's going to be one smaller, and then we work our way down. This one, when I first wrote it, didn't have an exponent. But whenever something doesn't have an exponent, we can always assume it has an exponent of 1. This last term doesn't have any x's in it at all. But really, we could write a little x to the 0 next to it, because anything to the 0 power is just equal to 1, and multiplying by 1 isn't going to change the number. So we really do start with the biggest power of n, and then we'll work our way down to 0, and 0 is the smallest that we're allowed to be. And the format that this is written in, this is standard form for a polynomial function, and it's called descending order. And descending order means we start with the term that has the biggest exponent, and we work our way down in order until we get to and finish with the term that has the smallest exponent. So descending order means the terms are written with the exponents in order from largest to smallest. And again, I will scan these notes, so if anybody wants these notes, I would be more than happy to let you have a copy of them. You certainly can be copying along as you go, though, as well. So if we have this standard polynomial function, every single term has possibly a coefficient and then an x with a power. A different coefficient, an x with a lower power. The dot, dot, dot means there might be a bunch more terms in this polynomial that follow that same pattern. We just don't know what they are. Coefficient x, and then constant term. There is no variable in that last term. Like I said a minute ago, we could say x to the 0, which mathematically we don't need to because x to the 0 is just equal to 1. And mathematically we usually don't write a power of 1 either. But these two terms, even though they look really different than the other terms, they do still follow that same pattern. So one really important piece of this function is that term in the very front, and that is called our leading term. That term is going to tell us a lot about what the graph of this polynomial looks like. And so that term, that leading term, it contains both the coefficient and the piece with the variable. And the thing about the leading term is it always has the biggest exponent in it. So you may be given a polynomial that's not yet written in descending order, and they'll ask you for the leading term. That doesn't mean they want you to tell it what the first term is that's written, because you can rearrange these terms any way you want to and have it still be the same. The leading term for a polynomial is always the term that has the largest exponent. Because if our polynomial is in standard form, that piece will be first. Another important piece for this polynomial, inside that leading term we have a leading coefficient. Now we said all of those a's were coefficients, but the leading coefficient will be the coefficient from the leading term, so it's the a sub n. And this polynomial also has a degree, so there's a degree of the polynomial. And it's one answer for the whole polynomial, even though we see several different exponents in there. A lot of times we think of degree and exponent as being the same thing, and they are very similar concepts. But when you talk about the degree of a polynomial, it's always referring to the largest exponent in the polynomial. And if we have that leading term written right there in the front, again, it's going to come from there. And being able to put the polynomial in descending order and identify that leading term with its leading coefficient and the degree are going to be really important when it comes to graphing. So not only that first term, but every term has a degree and a coefficient. So we could, and I'm going to show you an example, identify each term in the polynomial and its coefficient and its degree. So for example, if we have f of x equals negative 5x to the 4th plus 3x squared minus 8x plus 2. This polynomial has 4 terms, and terms are always separated by pluses and minuses. So if you point out where your pluses and minuses are, they separate it into 4 pieces. So each term individually has a coefficient and has a degree. So the first term is negative 5x to the 4th. Its coefficient is negative 5 and its degree is 4. The second term is 3x squared. The coefficient is 3 and the degree is 2. The third term is negative 8x. That minus comes with it. So the coefficient is negative 8, and the degree, remember a minute ago we wrote this, is 1. When you don't see a power, you can always assume it's a 1. And the last term is just a 2. And again, also, we said we could write an x to the 0 next to it. That means we have a coefficient of 2 and a degree of 0.